All right. So it's a little justification why, being an astrophysicist, I'm giving this talk. I have published papers on zero. For example, is it a pointer or something? Or I'll do it here.
Probably the best if it'll show. See whether, yeah.
Yeah, that will be fine.
Yeah.
Okay. Yeah, I have written, for example, this article, Zero, a tangible representation of non-existence, implication for modern science and the fundamental, was published in a peer-reviewed international philosophy journal, Sophia, and is also a book chapter published by Springer, and one can read it here. Also, another article is a book chapter, A Philosophical Origin of the Mathematical Zero, published by Brill, and I am also writing a philosophical monograph, academic monograph on philosophy, non-existence, delving into the fundamental, which should be published by World Scientific London. So this talk will be based on these two articles plus something else I am writing now. So this talk will have three main sections. One is the philosophical base on zero. Here I'll try to argue that zero did not come from a practical need, but it had a pure intellectual origin. And then this origin had a philosophical base. And the second section is about the Indian origin of zero. Here I will focus mainly on the living evidence, some of the living evidences, and then about a particular book which showed some time constraint on the zero's origin. And finally, the zero's journey out of India and its implications. Here I would like to argue that there is a lot of scope, actually a necessity, to do some foundational work on zero, not in the way the mathematicians today or people today try to deal with zero, but in the way the ancient mathematician dealt with zero. So first, the philosophical base of zero. At the beginning, I want to confirm that we consider the mathematical zero, which is an independent number with a set of basic operations, for example, addition, subtraction, multiplication, and division defined. So this is the particular zero we are considering. And why do we confirm this at the beginning? Because this definition of zero distinguishes Indian zero, which made a significant human progress possible, from the other so-called zeros, for example, zeros of Mesopotamia, Egypt, Greece, China, and that of Mayans. And the second point is, I would like to confirm that while zero represents nothing, and as we will see, originated from a philosophy of nothing, it is an existing mathematical object and it is clearly distinct from nothing. And I state this because the mathematical zero is sometimes used interchangeably with the philosophical nothing or nothing in general. We need to avoid this confusion. So zero came from nothing, but zero is distinct from nothing. It's a mathematical entity. So the question is, did mathematical zero originate due to a practical need? So here are very brief points, a few points. First, about the daily life. One does not need to consider the growth, measurement, building, buying, or selling of zero amount of anything. Thus, an independent number zero representing nothing is not required in daily life. Then we come to mathematics. Zero was essential for the development of the current sophisticated and advanced mathematics, but one could not have foreseen this before zero's basic mathematical operations were invented, and certainly not before zero was conceived as an independent number representing nothing. And finally, about natural science and technology, while many aspects of natural science and technology cannot be imagined without zero at the current time, the use of the mathematical zero in these disciplines has been a relatively recent phenomenon. For example, a number of ancient civilizations, such as those of Egyptians, Mesopotamians, Phoenicians, Greeks, and Romans, made a spectacular progress in technology without the mathematical zero. Thus, zero was likely conceived without a practical need. Now, there is a tendency to connect zero with the place value number system, the number system we use nowadays, and with the placeholder. The placeholder is considered to be zero. However, I would like to tell you that zero has nothing to do, zero's origin had nothing to do with the place value number system and the placeholder. In the place value number system, the position of a digit in a number determines its value. For example, this 1, 4, we write it this way, and its position of the 1 determines its higher value. In the Mesopotamian system, which for the first time used this place value number system, they have sexagesimal system, which has the, instead of our base of 10, they had base of 60. And therefore 1, 4, they would write this way, and their 1, 4 would mean 64 in our case. A connection between the place value system with zero is commonly made, almost implying that zero owes its existence to this system. But was place value system required for the conception of zero? Yes.
You say Indian decimal. Are you saying the decimal representation started in India?
So there were other kind of decimal. Even in China, they used decimal without a zero. They had a kind of gap.
Yeah, no, 1, 4 is 1 times 10 plus 4. So base 10. Did that originate in India?
As I said that, well, so place value originated in the Mesopotamia, but place value were also originated, it also originated in some other places. For example, China, India, and in the Mayans. Among these, the Mayans had the 20-base system.
Yeah.
China also had the 10-10 base system, and India also had 10-base system. But China did not have zero. They had this gap. So, yes.
When you say that the zero doesn't have a practical use or wouldn't have emerged from practical considerations, I mean,
That's not my take.
if I'm a baker and I employ someone in my baking shop, and I come at the end of the day and I ask how many people bought bread today, and it was a very bad day, and they say nobody bought bread today.
They would say nobody. They would not say zero. We can say zero today, but millions of bakers did it before the zero's invention. They said nobody without zero.
Maybe not bakers, but to some degree, people started bartering and making banking systems and keeping tabs of debts. So, you've cleared a debt when it's not on one side or the other.
Mesopotamians dealt with debts all the time. They never used zero, without zero. All right. So what I tried to say that, yes, place value number system is very useful to deal with big numbers, because with a limited number of numerals, you can make big numbers. Just its position gives a higher value, and therefore the same numeral you can use for many numbers depending on its position. But it doesn't have to do with anything with zero. So place value number system doesn't have to give rise to zero. Zero could have been included in any other number system. There are many other number systems, Greek, Romans, and many other number systems everywhere in the world, which are not place value system. They could have zeros. And one second. So, and let's see that how can that happen. Let's consider this following extreme case, which is impractical but notionally possible. So a number system's worth depends on that how you can make big numbers with a very limited number of numerals. Suppose consider that the most rudimentary number system, that is every number has a different symbol, different numeral. It's impractical but notionally possible. Even then you could have a zero in that system. Even then you could have zero's basic operation in that rudimentary number system. So zero, the place value number system was not required to invent zero or think about zero. Therefore, clearly the conception of mathematical zero does not require a place value number system. And since placeholder appears in the place value number system, the placeholder also doesn't have to do anything with zero. You had a question.
Yeah, so I just want to get clear on what you mean by having a notion of zero. Do you simply mean having a symbol that somehow represents?
A lot of people try to think zero from its symbol, but symbol doesn't mean anything. It can have any symbol. It's the notion, it's the idea of zero, it's the concept of zero that is zero. So there were multiple symbols of zero in the literature. In India, first they used to write zero as a point, and now they write as a circle. So yes.
But I guess I'm just, so, saying nothing, or so, the debt was canceled, or having a gap in the number system, all of those for you, they don't count as notions of zero because
the concept of zero was not there. Zero is nothing. So why would you deal with nothing? We always deal with something around us. So the concept of nothing, now you have zero, you can think about it. You very easily think about zero. But when the concept of zero was not there, it would be very surprising to say something about nothing. So why do you need a nothing in anything? So you deal with everything without something, with something. You do not need a symbol for nothing.
Okay, maybe we can talk later. I guess my question is simply like, clearly the ancients, they had a concept of nothing, but they didn't have a concept of zero. So I just want to get a distinction there.
Zero is a representative of nothing, and it's a mathematical representation of nothing. So in mathematics, why would you need a symbol for nothing? That's the point. So you count everything. So you count cows, or you count some other things, trees. If there is no cow or no tree, you do not need to count. And the idea of number came from counting. So if there is nothing, you are not counting anything. All right. So I'm not going into the details about it, but Mesopotamian placeholder was just a separator or punctuation mark. It didn't have any same for the Chinese, and so it didn't have any mathematical operation. It did not have any philosophical base. It's just a separator. And if they use, for example, the number 60, we have a zero at the end. Mesopotamian never used a placeholder at the end of a number. They just kept it blank. So it was just a separator, punctuation mark. It had nothing to do with today's zero. So if a practical need did not give rise to mathematical zero, then it must have been conceived purely intellectually. What could be the intellectual source of zero? Zero implies nothing, and hence it is expected that a philosophy of nothing would stimulate the idea of mathematical zero. Now here, in this paper, I have probably for the first time systematically categorized nothing. And these four kinds of nothings are balance nothing, absence nothing, emptiness nothing, and non-existence nothing. So to quickly give some example, what is a balance nothing? For example, K minus K would be a balance nothing. Two forces which are equal and opposite to each other would be a balance nothing. Then there is a particular philosophical school, Sankhya of India. There is an unmanifested fundamental substance called Prakriti that is also an example of balance nothing, because when this balance is, according to this philosophy, when this balance is disturbed, there is fluctuation and there is creation, according to this philosophy. And then even in modern science, the vacuum is not a pure vacuum. There are always fluctuations, creation of particles. So this vacuum, when there is no particle is created, there is something which is the balance nothing. Thus, a balance nothing is a secondary to multiple existence and is a existence itself. Yes.
So where does the concept of shunya fit in? Right, there is a concept of shunya.
I'll come to that. Yeah. So here I'm talking about the 4 categories of nothing that I proposed in my paper. And then the absence nothing. Absence nothing also implies the absence of a specific thing. It is also a secondary of that thing which is an existence. Therefore, it itself an existence. It's not non-existent. So both balance nothing, absence nothing, they are actually existent. Emptiness nothing is also an existence because it requires a container. So a container has to be empty. For example, if you consider empty space, not a glass of water, not an empty glass, but more abstract things like empty space, empty set, they are also, the set and space is a container. And therefore, and those are existence. Therefore, emptiness nothing is also existent because it is secondary to some existence. But finally, non-existence nothing is the absolute non-existence. It is the pure non-existence. So question is, what category of nothing could have given rise to the number 0? So let's consider balance nothing. Suppose balance nothing gives rise to 0, which means k minus k equal to 0 would be the definition of 0. But this k could be any numbers. So 0 would be defined non-uniquely by many numbers. So that means 0 is not an independent number. It depends on all other numbers. When we consider number 7, we do not define it by subtraction. We do not define it by 20 minus 13. We define it by 7 itself, counting, for example, 7 trees. So if 0 is a unique number, it cannot be defined this way. More than that, that k minus k equal to 0, if you write it 0, it requires the prior understanding about 0, the concept of 0. Only if you know what 0 is, that concept or notion you have about 0, then only you can write k minus k equal to 0. Therefore, k minus k equal to 0 cannot define 0. So balance nothing does not give rise to the number 0. Similarly, for absence nothing and emptiness nothing, they depend on something that is absent or a container, as I mentioned. If we define 0 by absence nothing or emptiness nothing, then 0 again will depend on a number of numerous things. So 0 will not be a unique number. 0 would not be independent of other numbers. So for example, absence of 7 is 0. Absence of 14 is 0. So if 0 is a unique independent number, it cannot depend on other numbers or other entities, other existence. Therefore, it cannot also be absence nothing or emptiness nothing. Hence, a notion of absolute non-existence of the non-existence or the non-existence nothing perhaps provided the conception of the mathematical 0.
It seems to me in modern mathematics, we define 0 relative to other things.
Yes.
As, for example, an additive identity.
That we do many things, many ways we define 0. For example, the reference line. We think about that, yes, 5, 4, 3, 2, 1, naturally 0 comes. It does not. Because the zeros operation, for example, was defined in a book by Brahmagupta in 628 CE, and the reference line went up to 0. That was done by Descartes, the same person, Cartesian coordinate. That was in 17th century, 1,000 years later.
Mm-hmm.
You see it your phone, you see your computer keyboards, 0 does not come before 1. It comes after 9.
I'm more thinking of the fact that it's the additive identity, for example. I mean, that's more how I would normally think of.
That's the thing. The number comes first, the concept comes first, then comes your addition and subtraction, multiplication, everything. You cannot use those operations to define this, which those operations are based on.
Yeah, it depends on which mathematician you ask, but the category.
Yes, I'll come to that, yes. All right, so as I said that the first record of zeros basic mathematical operation is found in the book Brahmasputra Siddhanta, that is was by Brahmagupta, an Indian mathematician, astronomer. The book is dated 628 CE, and we exactly know the year because he mentions it. He was 30 years old. He writes that in the book. And the 0 attained the full status of a number due to these operations. These operations make zero entirely different from all other zeros of all other cultures. These made the zero a number, and this is the zero we use today. Now, such operation could not have been invented without a philosophical premise of nothing. So let's see a little bit of operations, very simple operations involving zero or other numbers. Zero's mathematical operations are different from those of other numbers and hence did not directly follow from such operations of non-zero number. Zero is different. For example, when we, even we humans made civilizations, even non-humans, the animals, they would know what is increase and what is decrease. Something is increasing, even animals would understand it is increasing. But animals would not be able to do addition and subtraction. So the increase and decrease, the concept of that came much before mathematics, subtraction and addition. So concept of increase gave rise to the notion of the operation of addition, and the decrease came the idea and operation of subtraction for all numbers, not for zero. For zero, you add zero or subtract zero, nothing increases or decreases. So for zero, the addition and subtraction, the concept of addition and subtraction came first, and there is no increase or decrease. So the concept, so it appears to be very natural nowadays that you have 5 plus 0 and you have 5. You have 5 minus 0, you have 5. 0 minus 5 is minus 5. So it's appears very natural. But that was first given in the book of Brahmagupta in Brahmasputra Siddhanta in 628 CE. There is no mention of such operations anywhere in the literature, anywhere in the world. So it was a kind of, it's a kind of groundbreaking idea. So it appears natural today, but its conception was very difficult because we are dealing with nothing. So one has to consider we are dealing with nothing that does not exist. So it's a very difficult conception. Once it is given, people keep on using it. Similarly, if you consider multiplication, again for multiplication, we can, what is C equal to C into 0? C into 0 is 0. How? Because I can write 0 equal to k minus k and do this and try to prove C into 0 is 0. That's what people try to do everywhere. It's not correct. I showed already that k minus k does not define 0. It's from the zeros concept that we can write k minus k equal to 0. Therefore, probably the C into 0 equal to 0 came as a premise, just like addition and subtraction. It also came as a premise. Not by any mathematical proof, by premise. And it can be premised from the philosophy of nothing in the following way. Note that C into 5 means 5 C's. Similarly, C into 0 implies no C's. That is nothing. Or mathematically 0. So C into 0 equal to 0. It's just given. It's just premised this way. There is no proof of it. You can do other proofs based on that, but you cannot prove that. So, thus, 0 and its operations were premised and not proved. This is not surprising because even for the number systems, which mathematics generally stands on, was also premised. So, our mathematics started from counting. Then came the concept of numbers. Then we built the entire mathematics based on that. We cannot prove the premise of numbers. Mathematics started from there. Similar for 0. Only thing, 0 did not start with counting. It started with a philosophical base of nothing, which is much more abstract. And this is a general comment that might help. Every proof requires a premise, and hence the premise is the primary, and the proof is a secondary. A premise does not necessarily need a proof. but a proof always needs a premise. Now, what does the premised rule of zeros multiplication tell us? So let's see a little bit into the multiplication with zero. There are two notable aspects regarding the rule of zeros multiplication. Unlike other numbers, zero collapses all numbers to itself, all numbers, or nothing by multiplication. And second, hence all numbers have the same standing for zero. If you consider multiplication, then zero deals with all number in a similar way. It collapses all number to itself. If it is addition or subtraction, irrespective of which number it is, it preserves that number. So zero deals with all number in the same way. The first aspect, that zero collapses to all number to itself, implies that multiplication with zero notionally unbuilds a number, that is, makes it nothing or zero, is the philosophical concept. The second aspect suggests that zero deals with all number in the same way. It implies that zero is fundamentally different from non-zero numbers, which is consistent with the notion that zero represents non-existence, while all other numbers together represent existence. So all other numbers are basically existence. Zero is non-existence. Zero is different. So zero has at least the equal standing with all other numbers. Its conceptualization is at least as important as the conceptualization of all other numbers. Yes.
So it would also, it's a non-zero number that also treats all non-zero numbers in the same way. As I guess I'm wondering about like how it's like fundamentally different from non-zero numbers.
Yes, that happens. There are some identities, and one is that identity, right? But one is again existence. We count one. We can count one,
Right.
but zero we cannot count anything. So it's the based on nothing, that is not existing.
Okay.
So I'm not going into the details about this building and unbuilding, because that will be too much for this talk. It will take a long time. Otherwise, I would talk about little bit about zero by zero. I have a slide, but at the end, but I'll not talk about in the main talk. So now, Indian origin of zero. So quickly speaking, that there are many,
Zero factorial.
So all these things are defined much later. So how it premise it, how you define it. So yes, I'm not going to that. So I'll say a few points at the end, that how one should deal with zero and why one should consider the philosophy of zero. So all these things are very recent, I would say, that premise about zero, or the way we deal with zero. So the origin of mathematical zero can be probed using different types of sources and evidences. For example, there could be evidence from manuscripts, there could be evidence from inscriptions, but we are not considering that here. We are mostly considering the living evidence here, which are generally ignored. So here are some examples of, say, manuscript. The Boxshally manuscript, which is in the Oxford, is very famous, which mentions zero as a dot. And the earliest version of this manuscript has been dated with radiocarbon as 3rd century CE. So then this inscription in Cambodia, where there was Indian culture. So this number at the middle is as a dot, and the whole thing gives the year 605 in Shaka system. You add 78 to it, you get our normal year system, which is 683 C. And first time in India, the zero as a circle appeared, as we know, it's a temple in India, and in 876 CE. But we are not considering this, and we are considering living evidences. So because the how many, first of all, the particular symbol, specific symbol of zero is not, as I mentioned, is not that important. What is important is what zero represents, what's the notion it brings with. And second, how commonly a numeral would be found in a book or manuscript or inscription depends on different factors, including the various practices in that culture. So this was not the widespread culture in India. What happened in India was the day-to-day calculation used to be performed on the dust spread on a board or on the floor. This is why the India mathematical calculations were known as dhuli karma or dust work, and the arithmetic is still known as patiganita, which means the science of calculation on a board. So this means the writing inscriptions or writing in a book were not very frequent in India. They would do it on the just dust and just delete it. On the other hand, a living evidence like a philosophical tradition and word numerals, which we will briefly discuss now, can provide a larger picture of cultural background, and it provides a continuity over millennia. And hence, it could infuse a much required broad confidence. Such a perspective could be missing for isolated manuscripts or isolated inscriptions. A study of living evidence is complementary to other studies, of course, to manuscripts and the inscriptions, which are also very important to probe the origin of zero. So one slide on the philosophy of zero. So, which is also a living evidence. And I'll just mention a few examples. The concept of nothing is deeply entrenched in Indian culture and philosophy. And here are some examples. For example, the so-called Nasadiya Sukta or hymn of creation of Rig Veda, which is an ancient composition, I would say, because I'm not saying book, it is a book now, but that time it was not written. So it's a composition of the ancient Indian book Rig Veda, which might have been composed before 1000 BC. The hymn starts with, then even nothingness was not, nor existence. I take the translation from this book. It also mentions that one which came to be enclosed in nothing. So nothing was mentioned even before 1000 BC. And then there is the so-called Nirguna Brahman, or the absolute without qualities of Upanishads, which is another set of compositions of ancient Indian philosophy that might be somewhat close to non-existence, nothing. Again, I have already mentioned that the unmanifested fundamental substance, Prakriti, of the Sankhya philosophy of India, that can be also an example of balanced nothing. And finally, the Indian Buddhist school of Shunyavada argued that everything is empty. This Indian philosophy of nothing is still valued in various Mahayana sects of Buddhism in various countries. For example, among them, the Zen philosophy of Japan is famous. They are based on one of this Mahayana Buddhism, which came from this Indian Shunyavada. Actually, the Indian word for dhyana, which means meditation, became the Chan in China, which was a sect based on Shunyavada. Then when it went to Japan, this Chan became Zen. So its original word is dhyana, meditation of Zen. So all this provides a living evidence of the philosophical background of the mathematical zero. And then I come to word numerals. Word numerals. Another living evidence of the Indian origin of the mathematical zero is word numerals. This is a way of expressing numbers by specific words, which are arranged according to the place value number system. Why would the ancients use words? Because in India, the tradition was everything including the mathematical wisdom and everything, scientific, mathematical, astronomical, everything, they would write in verses. They would write in verses so that people would remember them easily, and that can be transmitted from one generation to next generation even without writing. So that is why they used word numerals. The word numerals were developed in India likely in the early centuries of the Common Era. Many words were assigned to represent each of the numbers from 0 to 9 and even larger numbers. For example, Chandra or moon is one of the words representing 1 because moon is unique. Similarly, Paksha or fortnight is one among many words representing 2 because there are 2 fortnights in a month. There are a number of words to represent 0 as well. For example, Shunna, which is emptiness, Kha, which means sky, and Bindu, which means point. All of them would represent 0. And they are there. So I say that word numerals are not words. They are actually numerals, only written in words, represented by words only due to cultural reason, as I said. How do we know this? Because not only their arrangement is according to the place value number system, but also they have right to left arrangements. That is least important digit to most important digit. And that is the way we do our mathematical operations, subtraction, addition, multiplication, everything. So word numerals are actually used for mathematical, they were used for mathematical operations. Here is an example of the ancient Indian astronomy book, Pulisha Siddhanta. So this is mentioned there, these big numbers from the right to left were mentioned as Kha, which means 0, Kha again, which means 0, Ashta, 8, Muni, Rama, 3, or like this. So here we note that unlike the Mesopotamian placeholder, 0 was used at the end of the number here, indicating that this 0 was not a mere separator or placeholder, it was a number. Moreover, given that there are several words to represent 0, like for numbers 1 to 9, and that all these words were words for 0 suggest nothing. For example, Bindu or sky, the Bindu means point, or sky, or Shunno means emptiness, all were somehow kind of connected to nothing. This indicates that the Indian 0 is an independent mathematical number founded on the idea of nothing. Thus, this 0 is in the form of word numeral is the same mathematical 0 we consider. And even in Indian, as I mentioned, Indian mathematics books typically do not include calculations using symbols as we do today due to cultural reasons. Even Brahmagupta's book, Brahmasputra Siddhanta, as I mentioned, it gives 0's basic operation, but mentions 0 as Kha, sky, Akasha, sky, Shunna, emptiness, etc. Thus, that of word numerals are actually numerals, and 0 in the form of word numerals is really the mathematical 0. This is extremely important to probe the origin of 0 because it's a living evidence, and even today, children in India are taught these word numerals. So it's a continuous thing over millennia, and that gives a very good confidence. Unlike an isolated inscription, unlike an isolated manuscript, this is a living evidence of 0 in India. Now I come to a book to constrain, put a limit on 0's time a little bit. It's a prosody, so-called Chandashastra or prosody of Pingala. It's dated between 2nd and 5th century BCE. So this amazing compendium is a very rigorous study of meters and a treasure of many pioneering mathematical applications. But here, for example, permutation, combination, Pascal's triangles, etc., all were for the first time in a cryptic way appeared in this book. But here we are interested in a particular problem which mentions 0. Now, before telling the exact problem the question asked by Pingala, I recast this question in a modern way. The question is, suppose there are n empty boxes as shown here, and there are balls of two colors, red and black. Each box can contain one ball. We have to fill all boxes with balls. How many ways can we do this? This is the problem. So you know the first box we can fill with either red or black, 2 ways. For each of them, the second box I can fill again 2 ways. So if there are n boxes, I can fill it 2 to the power n ways. That is simple. We can do it with our modern mathematical conception. This conception was not there in the early times. Such conception first appeared in this book by Pingala. Now, Pingala asked the question in a different way. It's a book about meters. It's a prosody. Pingala considered n syllables instead of n boxes, and red and black balls were long and short syllables. His question was, how many ways one can arrange long and short syllables to form a string of n syllables? That was his question. And he gave an algorithm. And this is the algorithm. Yellow is the first part, left side, blue is the second part. So let's consider n equal to 6 to give an example. I start with 6. This is the original number. Algorithm says that it is a even number, so half it. You half it, you get 3. And because you half it, you write a state here by 2. Then you start with 3. It's an odd number. You subtract 1. You get 2. You write the state here, 0. Now 2 is an even number. Again, you half it, therefore. You get 1. And because you have halved, you write the state 2. So when you subtract, you write the state 0. When you half, you write the state 2. That's where you go. And you go this direction, come to 1, you stop. Then you do the second part in the opposite direction. Idea is, when the state is 0, you multiply it with 2. When the state is 2, you square it. So that way you go up. And if you do, you will get 2 to the power 6. That's the answer. It will work for any values of n. And one can think a little, and one can, in the modern way, one can understand why it works all the time, this algorithm. And this is the sutra, or this is the rhyme that he mentioned in his book. I mentioned it one, it's in Sanskrit. Dirarthe rupe shunnam di shunne tavadadhe tadgunitam. I'm not going to explain it because it is extremely compact and cryptic. But note that the shunna, word shunna appears twice. This Indian word shunna implies emptiness or non-existence generally, and also the number 0. Shunna becomes cipher in the Arabic world, and it became cipher from there in the Latin word. The word 0 came from cipher or cipher. So all this is good, but question is, look at these states, 2 and 0, 2, 0, 2, 0. You have it, you put 2. You subtract 1, you put 0. It's only states. You are not using this number for calculations. It's only states. Based on this state, you are doing calculation here. Question is shunna or 0 required in Pingala's algorithm? Do you really need to write 0 here, 2 here? One could replace 2 and 0 here with any 2 numbers or any 2 letters, like A and B. The algorithm would work just fine. And that is the point. That is the point. While Pingala could use any symbol like our B, he used specifically 0. Would he do that? Question is, would he do this if he were not confident that his readers, including students of poetic meters or prosody, were fully familiar with 0 and its symbol at his time, that is between 2nd to 5th century BC? So if zero and its operations, not operations, at least zero as a number were not very familiar, very common at that time, he would not definitely use zero here. He would put any letter or any other common number there. But he put zero. He was confident that zero would do, serve his purpose. So that gives a constraint on the time of zero. Or, if this is true, then zero was conceived before this period, 2nd to 5th century BC. Now with this, I come to the last section, that is journey of zero and its consequences. So as we have seen that zero has two aspects, philosophical and mathematical, with the latter depending on the former. The journey of zero out of India somewhat separated these two aspects, with former being more valued by some cultures and the latter by others. In the first millennium CE, both aspects likely spread in Southeast Asia and East Asia, where Indians either established colonies or at least exerted a significant cultural influence. But while the mathematical aspect of zero did not give rise to modern science in this part of the world, its philosophical aspect is still valued there, as I mentioned earlier, by sects of Mahayana Buddhism, for example, Zen, etc. However, mathematical aspect of zero and the Indian decimal place value system were accepted, used, and popularized in the Islamic Abbasid Caliphate, which was established in Baghdad in modern day Iraq in 749 CE. The first few generations of Abbasid Arab caliphs patronized the aggressive acquisition of knowledge primarily by inviting scholars and by translations of books, mainly from three sources, Indian, Greek, and Persians. There was this famous scholar, mathematician Al-Khwarizmi, a scholar under the service of Caliph Al-Mamun in Baghdad in early 19th century. He wrote a book on computation with Indian numerals and another book on algebra. Actually, this book is known as Al-Jabr something, and that gave rise to the word algebra. A subject which was developed with abstraction and general rules, that is algorithms, by a number of Indian mathematicians before Al-Khwarizmi. But the philosophy of Islamic world was greatly influenced by that of Greeks, including the rejection of nothing, philosophical rejection of nothing by Aristotle. So it started in the Greek world with Parmenides, and then Aristotle accepted it. He would not consider nothing. He would not accept nothing. And that actually kind of influenced many things. The zero came into conflict with Aristotle's doctrine and consequently was treated as a mere number separated from its foundational philosophy of non-existence. And that is the important thing about how we deal with zero nowadays. Similar conflicts repeated in Europe after a few centuries when Fibonacci from Italy learned Indian numerals and calculation techniques from the Arabic world in North Africa and introduced this new knowledge in Europe in 13th century CE. But even after many debates and multiple bans, the Christian church tried to ban zero several times. But as someone said, the bankers or someone you said, yes. So bankers and the traders, they loved zero. That's why the Christian church's ban did not work. So, and the arithmetic algebra developed based on it could not be ignored or suppressed, as I said. Finally, a partial rejection of Aristotle's doctrine and the acceptance of mathematics, including zero, developed in India and later in the Arabic world, marked the rise of modern science, particularly mathematics, astronomy, and physics. But while this science relies, that is the important point I want to make through this talk, that while this science relies on the notion of non-existence through zero and could not be developed without zero, the European culture in which modern science grew largely continued to ignore the philosophy of nothing due to a deep-rooted Greek philosophical base and bias. Consequently, techniques to circumvent or avoid zero were developed. How many minutes do I have?
You have another 8 minutes.
Okay, great. And here I will give an example how the modern science try to.
Sudip,
Yeah.
I know, I mean, you are short on time, but you say Aristotle didn't want non-existence.
Nothing. So
Nothing.
I would say nothing. His idea of nothing was mostly about emptiness. So the idea of non-existence were not there at all.
Okay, but Aristotle simply said it, or he had some reason?
So Parmenides had some reason. He tried to give some argument considering the space and various things, and Aristotle simply kind of endorsed it. Parmenides was before even Socrates.
Who?
Before even Socrates. So you know that Aristotle's teacher was Plato, and Plato's teacher Socrates. So Plato wrote that when Socrates was very young, he once met Parmenides, who was very old.
I see, okay.
So
So it just,
yeah,
it just accepted, I mean, there was no real argument against that.
Parmenides had some arguments about space, etc. But what we are considering, space is related to emptiness, and it's a very specific thing. What we are considering is much more abstract, non-existence.
Yeah.
And even if we consider emptiness, we do not have to consider this our physical space. So it can be much more abstract. So he considers some specific very space and tried to argue Parmenides. And even those people who are not bothered about the non-existence, they also do not actually take, it's a modern philosophy book, if you look into, you will say that Parmenides' arguments were wrong. So, all right. So all the time nowadays, what we do in mathematics, I would try to argue, and it could be a little bit controversial, but I think it's true that we try to kind of circumvent it in various ways. Consider calculus. Calculus is dy dx, is basically a science of 0 by 0. Even integral calculus is essentially 0 into infinity, which is equivalent to 0 by 0. So calculus is equivalent to 0 by 0. And the idea was to how to, well, one can see this paper or book chapter for details. I do not have a lot of time to discuss it, but it's basically how to replace 0 with a very small quantity, which we call infinitesimal, and do the operations. That's how calculus works. It is very successful because calculus is a branch of algebra actually, which gives the calculation of change. And when you have a mathematics that calculates the change, then you can predict. And that's why in natural science, calculus is extremely, extremely successful. And it's the best, it's the foundation of almost the modern physics, etc., and many, many, many fields. But the thing is, if you see from the foundational point of view, it's basically 0 by 0. And how you avoid the 0, it depends on that. You take limit, then also you are avoiding 0. You use your L'Hopital's rule, that is when you have 0 at the bottom in the denominator, you just use the derivative. That is also, then also you are trying to avoid the 0. So everything is about avoiding 0. So at best, this is an approximation. At the worst, this is improper for two reasons. Mathematically, the operations of 0 are different from those of a non-zero number. As I tried to, in a very limited time, tried to argue that 0 is on one side, all other numbers on the other side. Philosophically, non-existence cannot be replaced with an existence. This is philosophically, I would say, completely incorrect or wrong. But that's what we are doing all the time. And we get our numbers, our predictions correctly, of course. Why do we get correctly? Why does it work satisfactorily? Because we, being finite existence, can access only finite existence. Non-existence is only a notion for us. We cannot have any non-existence. If you think about non-existence, the thinking is existent. You never can access a non-existent. So it's only a notion. And it works, therefore, for the natural world, for the natural science. However, and therefore, can we say that since the techniques of avoiding 0 appear to work for practical purposes, can we not define 0 by its basic operations without considering its philosophy? Can we not completely ignore its philosophy and do whatever we are doing now all the time? So there I have some points. Note that zero's basic operations, which were conceived in India, involve zero itself, and zero was not replaced with non-zero. When the ancient mathematicians in India considered 5 plus 0 equal to 5 and 5 minus 0 equal to 5 and 5 into 0 equal to 0, they considered zero. They squarely used zero. They did not replace zero with an infinitesimal or any other existent quantity. They used zero. They were very bold. They used zero itself, the zero that represented nothing. What we do nowadays in most cases, whenever we cannot deal with zero, we are not bold enough to make a premise like those ancient mathematicians to use squarely zero. We replace with an infinitesimal, which is not existent, and then do our analysis. For example, take a limit that tends to go to zero, but we never include zero. So that's the way we do. Suppose we would not do this. Suppose we are bold enough to squarely face zero, even in today's mathematics. Probably everything would change. I do not know how. So that's what I try to mention, that this was possible because such operations could be premised based on the philosophy of non-existence independent of the non-zero numbers. But when zero traveled out of India, understanding and operations of zero were not developed further, I would say. Now, people, it can be controversial. There are many mathematical works on zero, but I would say there are almost none of them are bold enough to consider zero directly, squarely. They would replace zero with something, and that's the wrong thing from the philosophical point of view, from the point of view of zero's foundation. All that happened was to devise techniques to circumvent zero using non-zero numbers. This was because zero's philosophical base was ignored. Therefore, if one ignores zero's philosophy, one has to give up any understanding not only of zero, but also of everything developed based on the concept of zero. Moreover, no further development of zero's operations will be possible if we just start with the operation just handed down to us and just go with that without considering any foundational thought. Besides, since the techniques of avoiding zero involve approximation, a more fundamental understanding of nature could be missing if the idea and operations of zero are not further developed in the basis of the philosophy of nothing. Because you see that when we make approximation or assumption, the inquiry terminates there. We make an approximation or assumption, inquiry terminates there. Only we can proceed, we can progress only when we question that assumption or approximation. Moreover, think about the ancient time. It is likely when this philosophy of nothing, which gave rise to zero, this was apparently a radical, impractical, and unnecessary entity. It was not realized how it would fundamentally affect the course of human civilization. This suggests that the current rejection of the philosophy of nothing may also hinder an unforeseeable and deeper understanding. So maybe we are missing a lot of things by ignoring the philosophy of zero. The ancients did not ignore the philosophy of zero. They gave rise to the concept of zero, notion of zero, from the concept of nothingness or non-existence, and then they squarely handled zero. They made a premise. They premised the operations of zero, which are completely not at all required at the time. And I'm sure that many people laughed at them who did this because there are no use of it at the time, at the beginning. But that gave rise to the entire our progress in science and mathematics. So if we ignore this now, then probably we are missing some progress which we cannot think of. Finally, there is an important difference between philosophy of zero and the non-zero numbers. See, there are many philosophies with numbers. For example, one example is our Greco-Phoenician mathematician of ancient time, Pythagoras, he popularized the philosophy of non-zero numbers. But zero's philosophy is different because for non-zero numbers, those numbers were primary and philosophy came later. Philosophy was secondary. In case of zero, the philosophy is primary. The idea of or notion of zero came out of that philosophy. Philosophy is primary, zero is secondary. So philosophy is absolutely required for zero, may not be for other numbers. So here is the take-home message. A philosophy of non-existence gave rise to the concept of the mathematical zero and its basic operations in India. That's my view, of course. The tendency to circumvent zero and to ignore its philosophy, which began plausibly when zero traveled out of India, contributes to the progress of science and mathematics within the current framework. Of course, we have progressed spectacularly using our science, using our mathematics, all of which were based on zero. So within this framework, in which we ignore the philosophy of zero, still we have, using this, we have made spectacular progress. But it leads to approximation. And possibly we are missing something. Possibly this that we ignore the philosophy of zero and we refuse to face the zero squarely as the ancient mathematicians did. That probably may hinder a deeper understanding, which we do not even know what we are missing. So here I stop. Thank you.
So unfortunately, we are out of time, so I'm sure you can ask later. We'll be around. So thank you again, and